Okay, so today we are effectively reviewing what we've already done. This is the beginning, lesson 1 on module 4. We're going to be talking about multiplying and factoring polynomial expressions. Some of this will go over vocabulary, but really this should be a lot of review for you guys. And we've talked about this, and I think you guys actually enjoyed this as well. So the first part says write an expression for the areas of the two rectangles in the figures below. If you remember, your rectangle area is length times width. So we could write this out 2z, this side, times z, and we can condense that. And you combine like terms. So when we're multiplying, we're going to combine these two. So it'll be 2, and then it'll become z squared. So that would be on this side. For this side over here, we're going to have 2z times 8, so 2z times 8. And so for this one, we can't, there's no z's to multiply together. So we'll just multiply together the constants. So 2 times 8 is 16, and then we'll have z as well still there. So that's pretty basic. Now we're going to work on, this is where we actually start getting the polynomials. So now write an expression for the area of this rectangle. So for this rectangle, we have this length, this length times this width and this width. So we could find the area of this rectangle first, which is 2z times z. And then we can also find the area of this rectangle. So it'll be plus 2z times 8. And so then we're going to have this rectangle size plus this rectangle size. And so now we're going to have 2z times z. So that'll be 2z squared. And that'll be plus, I know these z's look a lot like 2's. I'll put a dash through them. That one's hard. Okay, so it'll be 2z squared plus, and on this side 2z, or actually be 16z, because it's 2 times 8. So it'll be 16z. And that would be it. That would be the total area of the rectangle. So what we're going to be talking about is multiplying, kind of like how we would do here, where this would be actually 2z, another way to write it, times z plus 8, and this would be our polynomial. So we're going to talk about multiplying as well as factoring out and a couple of those things. So example 1, Jackson has given his friend a challenge. So the area of the rectangle in square units is represented by 3a squared plus 3a for some real number a. So a is just going to be some number. It could be 2, it could be 3, we don't know. It's kind of unimportant right now. So it says find the length and width of the rectangle. So there are a lot of different possibilities we could have here. This is where we're factoring out the greatest common factor. So 3a squared plus 3a. So this is when we look at these and say, okay, what do these two share? So this term and this term, they both have a 3. So one possibility is we could do 3a squared plus a. Or we divide both of these by 3 and stick it out front. So another example, another way we could do this is you have 3a squared plus 3a. They both have an a, so we could pull out an a from both of them. So then it's a out front, 3a plus 3. So those are two different possibilities. Another possibility in the last one is if we had 3a squared plus 3a, then we could also factor out both, the 3 and the a, because here we still have a 3 we can factor out, here we still have an a we can factor out, so we can pull both out, 3a, and then we're left with inside here, a, and if we divide 3a by 3a, it's going to be 1, so it's plus 1. That way we can still multiply this back in and get the same number. So that's the factoring side of it, and this we've done before. It should be a bit of review. So the next part says factor out, or factor each by factoring out the greatest common factor. So a way we can do this is by writing the prime numbers of this, and we'll talk about it down here, but we could write out the prime numbers. So for this one, for 10ab, we could divide it out. So 10 we can divide by 5, and that'll give us 2, and we still have A and B. So that's one side. The other one is 5A. So this one we can split up, 5 times A. So now we can really see which ones they have in common. So the 5 they both share, and the A they both share. So we can pull that out front. So it'll be 5A in the front, and inside will be 2B plus 1. You always have to leave 1 if you are removing everything here, because we have to be able to get the same answer. So you could check yourself here. You take 5A and multiply it back in to each one. You're distributing it. So then it'd be 10AB plus 5A. And so we end up getting the same thing when we were to distribute it. Okay, so then for this one here, you can do the same. I want you to take some time and practice these two on your own. They're a little bit more challenging, so give it a shot and then come back and I'll show you how to factor them out. Okay, so for these ones, factoring them out, you can again split them up. So it'd be 3 times G times G times G, that's what G to the third means, times H. So that's 1. This one over here is going to be 3. If we divide 9 by 3, we're going to get 3 times 3 times G times G times H again. So then the last one is going to be plus 12. So then it's going to be 3 times 4, that's 12 broken down, times H. So for this one, we can only factor out what all 3 share. So all 3 have a 3, and all of them have an H. So we can factor that out and put that in the very front. So 3H. And then you can kind of come back up, cross those off, and what's left over, you're going to write. Remember your sign, don't forget that. So this is going to be a minus and a plus. So right here we'd have G cubed. The next one is going to be minus, because we still have this minus sign, 3 times G squared, and then plus 4. And that would be it factored out. So the next one, we can break it up again. You do 6x times x times y times y times y. And actually you can break this 6 up into 3 and 2. So 3 times 2 times x times x times y times y times y. Okay, the next one, so we can put a plus there. 9, it can be broken up, kind of like how we did up here. 3 times 3 times x times y times y times y times y. Okay, and 18, we can do 18 divided by 2, and you'll get 9 and 2. And you can actually break that 9 up again. So it's going to be plus 3 times 3 times 2. And then this y, we're going to have 5 of them. Y times y times y times y times y. So we can break it up that way. So then we'll go through. What do they all share? They all share 3. This one has a 2, this one has a 3, this one has both, but not all 3 of them share that. All 3 of them do not share an x, but all 3 do share 3 y's. So we can take 3 out front, y cubed, and then we'll just come back up here and cross them off. So we know which ones are gone. So then it's going to be 2x squared plus 3 times x times y. So 3xy plus, and that'll be 3 times 2, so 6 times y squared. And that would be our factored out. You can also look up here and say, okay, all of these can be divided by 3, 6, 9, and 18. There's nothing else they'd share, so you can put a 3 up front. You'd also look, do they all have x's? No. Do they all have y's? Yes. How many y's? This one has 3, so we could potentially take out 3. That one has 4, so 1 extra. So we can still take out 3, and that one has 5. Still has 3 in there, so we can take out 3 total. Just different ways of doing it. I know I've shown you how to do it this way before in the past, and I think a lot of you prefer that method. So just kind of a little bit here, the language of polynomials. So we kind of have to talk about previously prime numbers and composite numbers. prime numbers are are numbers that you can divide only by 1 and keep that whole number. So an example would be 7. 7 you can't divide by another number besides 1 and it stay a whole number. If you divide it by 2, that's going to equal 3.5. It's not a whole number, so 7 is prime. Another example is 1, 2, 3, 5 is another example. So those would be prime numbers. A composite number is a number that's not prime. So this is one where we can say 8. 8 can be divided by 2, that's going to equal 4, and that can actually be divided by 2 again. So that would equal 2. So if we were to figure out 8's prime factorization, would be 2 times 2 times 2. Composite numbers are when you have multiple prime numbers multiplied together. That's what's going to give us a composite number. So when we're looking at polynomials, when we're trying to get them down to their prime function, that's when we want to get down to numbers that we can't break up anymore. So an example up here, this would be the prime factorization where we have factored it and we are down to nothing they have in common. There's nothing we can take out. We have it all right here. So what we will focus on is sticking with integers. That means we're staying with whole numbers. We're not going to be factoring these currently down into fractions or decimals. We'll get into that later, but right now we're just going to stick with integers.